as far as I know, I mean, the appreciation of life, of course, goes back to antiquity, religions and so on. But I think that now that we understand how special we are, that really leads onto this ethics and this moral obligation, which I think is, in my view, it is really a moral obligation to do that.
So if we go into some of the technical details on how this would be pulled off, then let us know some of your suggestions in terms of how we would transport, so to speak, the material from here to elsewhere, depending on where that is, extrasolar planets and so forth, Michael.
Yes. Okay, now there are several options for selecting targets for this, and each has advantages and disadvantages. The most obvious is there is, for example, the Kepler mission, NASA Kepler mission out in space now that going to try to detect extrasolar planets about other stars, Earth-like extrasolar planets, relatively small, with livable properties. Once they are found, they would be an obvious first target. One question is, if there is life already there, will we, harm it? And I want to come back to that question later, but there might be, again, I don't necessarily think that there is life out there, but if there is, that is a legitimate question.
Yes.
The other problem is that they are relatively small targets. I think even if they are maybe 10 or 20 light years away, you have to aim very precisely to hit a planet, which is immensely further away than Mars, for example. It's very nice that we can land something on Mars. It's a great achievement. We're talking about something much more precise that we would have to do for that.
Yes.
There are two other alternatives which I think are preferable for several reasons. One other alternative is to look at solar nebulas, that is, planetary systems in the process of being formed. And what you have at that stage is a big mass of gas and dust that occupies kind of a planar circle about a new star, where collisions between the dust and rock pieces eventually build up new planets. So these are solar systems in formation, and there are several of them that are within 10 to 30 light years from Earth, which is manageable distance. One advantage is several advantages. One is that they are much larger targets. You don't have to hit a planet. When a planet, you have to hit within like an astronomical unit, which is called the Earth sun distance. Have to be as precise as that. The solar nebula are 100 times larger, so you have a much larger target, much easier to hit it. The other advantage is that in these new planetary systems, there is a good chance that some of these microbes that we send, these capsules, will be trapped in comets that are forming now, and they will be preserved, and then little by little, this dust and these collisions, it can be delivered to planets even billions of years from now, when the planet is ready to accommodate life. And the third advantage is that in those planets, which are just forming now, there is no chance for life to have started there yet. So we are not going to harm anything.
Yes, because I guess that's one, the moral question that comes into this picture as well is, what if life already exists on that place that we're sending it to? Although it might be in very primitive forms, we're still talking about a form of, infection, so to speak. We send our DNA and our microorganism, which might knock out the life that already exists on that planet. Is that right?
Yeah, but that's always the first question that people ask on this, and that is why my answer is, as I said, to go to the other alternative is, other than the solar nebula, is to aim at even at an earlier stage of formation, at interstellar clouds, which are very large masses of gas and dust, in which there are certain regions where it's more dense, and inside those dense fragments, you have more dense areas yet where new planetary systems are forming now. So there is no chance that any new life could have arisen there at all. So we can avoid this problem. Also, these interstellar clouds are yet much, much larger than even a single solar nebula. And with one mission, we can maybe hit a cluster of new stars and new solar systems. So usually they form in groups of maybe 10 to 100 of new stars. So with one mission, we can probably feed with life 100 new worlds for trillions of years in the future. So that's the other advantage. It is, to go into a technical detail a little bit, another nice thing about aiming at these interstellar clouds is that you can send, depending on the size of the capsule, and we are talking about millimeter, microns or millimeter size objects that we are sending there, but many, many of them. They will penetrate into this cloud, which is very thin on the outside, and they will be selectively slowed down when it gets thicker and denser, so they will automatically be stopped just where we want to aim them at. And we can select by the size of these capsules that we are sending, we can select where they will be stopped when they arrive there. Right.
One of the transportation methods as well that you suggest is basically ships with solar sails. Tell us about that, Michael.
Well, the most promising method that we have now for interstellar travel is solar sails, which is very, very thin films of material. I think we can get down nowadays to micron size thickness. And when solar radiation hits these objects, these sails, they can speed up slowly but continually as they are moving away from the solar system because of radiation pressure. They keep accelerating, and so we can get them nowadays to the speed of about 1/10,000 up to 5/10,000 of the speed of light. At that speed, so then it takes 10,000 years to travel a light year, or 100,000 years to travel 10 light years, or it would take even 1 million years to travel to this interstellar cloud, for example, which is about 500 light years.
We're talking about 1 million years, although, with this. Wow. How would microbial life survive this journey then, in terms of all the cosmic radiation? And that's a puzzle as well, because apparently, as you said before, life from elsewhere might have ended up here, but the question is, how do they survive in these cosmic conditions, Michael?
Well, for that reason, they would need to be well protected, and they would have to be protected. Well, inside rock phase, we can probably do better by designing shields. The factor that helps is that once we are in interstellar space, will be down to like 3 degrees Kelvin, which is almost 3 degrees above absolute zero. So they are very, very cold. They could be dehydrated, so made as inert as possible. This is an aspect that really requires research. There are also microbes that are more resistant to radiation many, many times than normal microbes. We would have to design probably payloads and microbes that, with experimentation and designing them, both to survive the journey and to survive a variety of conditions once we get there. We don't know if there's the temperature, we don't know the chemical conditions, the pH. There are